What's up, everybody? This is Coach Sharf, and welcome back to my Algebra 2 slash Advanced Algebra notes videos slash examples videos. Um, Today we are in our radical function unit, and we're looking at graphs of radical functions. So we're quickly gonna go over what we want to cover, what we will cover, and then we'll take a look at it. So this used to be later on in the curriculum. Right now we're at in the 2023-2024 school year, and what I'm assuming is going to be the curriculum for the next few years. This is actually this is the second potential thing we could have graphed, but we usually skip graphing logarithms. So this is the first graphing thing we've run into. I told y'all in class there's a lot of graphing in Algebra 2. Particularly if we do cover it all, even more so than in Algebra 1. And it's not just linear lines or quadratic parabolas with the U shape. So, we can do the opposite of that. The opposite of x squared is a square root graph, which is what we're looking at. We're also looking at cube root graphs. Again, y'all haven't actually seen x cube graphs. Those got moved to after this unit, but we are going to go ahead and look at cube root graphs. Usually when we look at a graph on the coordinate plane, we're talking about certain characteristics such as domain and range, x and y intercepts, several other things again that we'll cover later. Not necessarily going to see now. The only things we're really going to focus on in this unit are the domain and range, because they are going to change and be different based on whether you have a square root graph or a cube root graph. The main thing we're going to focus on, however, are transformations. So transformations ties back into the geometric transformations y'all did in Unit 1 of geometry last year. I'm not sure if this was the last year under the old standards. I don't know if under the new standards it's still in Unit 1 or not, but y'all did transformations of shapes on the coordinate plane at some point. So that's, vertical and horizontal shifts or translations, moving left and right, up and down on the coordinate plane, reflections, rotations, and dilations, making the shape bigger or smaller. Particularly with the square root graphs and the cube root graphs, really all the graphs actually, anything other than a shape, you can't really do a rotation because it's not coming from you do this to the certain points. It's not just certain points that are connected to form a circle or a square or whatever. Our graphs come from equations, and there's no way to put an equation that you're rotating a graph 90 degrees or 180 degrees or whatever. So we're not doing rotations, but we are going to look at the other ones. Okay. So with that being said, let's jump in. Let me share my screen. Hopefully I can see clearly. Again, I've been down to my last pair of contacts for a while, so I've mostly been sticking with my glasses, but they had a reflection, so I had them off for right now. But now that my box is a little, I'm going to put them back on. You can still see it a little bit, but hopefully it's not too bad. All right. So we're in our graphing radical functions assignment. Okay. Again, we did a brief thing in notes in class. I'm not even going to show you all that. Okay. The main thing we're going to look at is this chart of transformations, which I'll have to copy down and is here in the assignment. You can click on here to download it separate, or you can just, well, I got to log in. Hold on. I'm not logged in all weekend. There. All right. This. There's gotta be a way to turn this on the side, isn't there? There we go. Okay. I didn't know I could do that. All right. So now I'll put my little talking head in the actual corner. I'll zoom in. So I'm gonna give y'all a handful of functions. Okay. I'll give y'all a handful of functions, f of x equals whatever, which y'all realize what it is. And again, if we remember, y'all kind of see the examples here. I'm actually gonna have to annotate real quick. I don't, my little board isn't working, so I'm gonna try to do the best I can drawing with my finger. So what makes a radical function is I either have the square root or the cube root. I know that three's kind of big looking. And there's an x underneath it. Okay. So these are the parent functions, square root of x, cube root of x. And we'll look at how those base parent functions look in Desmos here in a minute. As far as my transformations go, anything other than x, square root of x or the cube root of x. So anything under, well, I'm not even say under, around. I'm gonna say around because you can have stuff in front as well. So anything with the square root or the cube root of x, it's not x itself. It's going to be a transformation. Okay. So again, big idea. What does that even really mean? Big idea. What that means is if I'm on Desmos, I do the square root of x minus 2. You can see my graph is now moved 2 units to the right. If I did square root of x plus 5, it moved 5 units up. Still got the same shape. If I did a reflection, graph back down, so yeah. Keyboard pops up. If I did the square root of negative x, out reflects. So anything I add other than x is going to change the way my graph looks. It's going to transform it. So that's why we call them transformation. Okay. And while y'all could take the parent function, square root of x, and try to compare it to our different graphs, because again, these are just one transformation, but let's say I did 3 out here, plus 6 over there, and it actually went that way because of the reflection, so we actually do minus 6, and then a minus 2. Now you're trying to compare this red graph to this purple one, and it's really hard to see. But if we just look at our equation and look at that chart that we had pulled up, everything that's not the square root of x is going to tell us what our transformation is. Okay. So again, what does that mean? What does that mean as far as what y'all learn and what the assignment is? So if we move my head, we exit out of this, pull up the homework, which everybody should have. Here's the homework. Okay. So you're going to have 8 equations. I already typed out 2 of them. So those are the ones that we're going to kind of go over here as examples. I already typed out 2 of them. It's got the different transformations I want y'all to do along with domain and range. So we will, after we do the transformations, we'll go type those into Desmos to talk about the domain and range. So let's look at this first one. I got the square root of negative x minus 2 plus 3. Square root of negative x minus 2 plus 3. Yeah, everything on here might have to zoom out one. There. All right. So again, this is gonna be a little tough to do since I'm not actually using the pen, but the square root negative x minus 2 plus 3. Yeah. There we go. All right. Square root of negative x minus 2 plus 3. So anything other than x is going to be one of these transformations, right? If you look at the first two, the horizontal translation, the vertical translation, which again, I shorthand as shift. So make sure I get this F in here and it looks like an F. Shift, okay? And it even says it here, graph shifts left to right, graph shifts up and down, okay? So my shifts are when I have a number somewhere after x. You got your function written out, you got x, and then you have a number minus 2, x plus 3, whatever. You have a number somewhere after, okay? If it's after it, but it's still underneath the line for the square root, it's still in the house, some y'all might say. That's a horizontal translation, a horizontal shift. And the shifts go the opposite direction you think it would. Minus 2, you think would be, if you're going left and right, you think would be 2 units to the left. It's actually 2 units to the right because our x is going 2 units to the right to counterbalance the negative 2. This is the basic explanation for it. You don't have to know the basic explanation, but you just have to be able to, if you got negative 2, look at this and say it's going 2 units right, which happens to be the case of this problem. It's exactly negative 2. So my horizontal shift is going to be 2 units to the right. Okay. We're going to, God, I'm going to have a hard time writing this out without the pen, but we're going to write all these out right now. Actually, let me back up. I'm going to try to do these in the order that they are on the worksheet. It's stretch or shrink, reflect over the x-axis, reflect over the y-axis, horizontal shift, and a vertical shift. Okay. I believe that's the order. I don't. There we go. I didn't have them. I did. Okay. So again, this is probably on me a little bit. Maybe I need to go back and switch the order. When I retype this for next year, but instead of kind of going down the order on our paper, I think it's just easier just to kind of go down the chart and say, do I have a horizontal shift? If I do, what is it? If I don't, put none. Do I have a vertical shift? If I do, what is it? If I don't, put none. Okay. So this minus 2 is going to be 2 units right. Okay. Yeah, I think I flipped the order of the terming. I know I did not think on your paper. So on the paper, again, pardon this, but I don't know where my pen from my little board went. So it's going to be right 2 units. Okay. If you put 2 units right 2 units, either way, the wording's fine. Vertical translation. So now I've got a number I'm adding or subtracting, but it is not in the house. Okay. I got the square root. Here's the top line. It's not underneath this. It's after, which I clearly have here with this +3. So again, when it's positive now and it's after the square root, this one is going to go the direction we think it's supposed to. So for the vertical shifts, we're going to put up 3. You got away from me there for a second. Gosh, up 3 units. Okay. Reflection. So if you look on your paper, it says reflect over x-axis, reflect over y-axis. It's actually split on your paper. It's one item on your chart here, but it's got both the reflection in the y-axis and the x-axis on it. And you can have both. This is not an either-or situation. Okay, you can have both the reflection over the x-axis and the y-axis in the problems that I gave you on this worksheet. So the light's kind of reflecting off. There you go. You already saw the PDF of it, or the Word document of it. You can have both negatives, okay? So that's why they're split up. So with the reflection, you're looking for any kind of negative sign in front of x. If it's attached to the x and still underneath the house, it's a reflection over the y-axis. If it's in front of the house and in front of the x, if it's in front of everything, it's a reflection over the x-axis. So this negative is attached to the x and still under the house, so there's a reflection over the y-axis. And I don't have a negative in front over here, so there's not a reflection over the x-axis. So y-axis, we're going to put yes. Again, pardon. I'm trying to do so that's bad. I'm trying to do this with my finger. And then for x-axis, we're going to put no. Okay. Now, stretch or shrink. Stretch or shrink. This one, there are 2 separate line items here in the chart, but I only have one here, okay? For this one, if you just look at a graph, it's basically, I don't want to say impossible, but it is very difficult to tell if you have a horizontal stretch or shrink or a vertical stretch or shrink or some combination of the two, okay? So you can't even rely on looking at the chart. You basically have to look at the equation and be able to tell. And on all the problems I gave you, I didn't give you a problem that has both a horizontal stretch or shrink and a vertical stretch or shrink. It's just going to have one or the other, okay? So for stretch or shrink, you don't have to put if it's horizontal or vertical. We're still going to put what's over here on the right. So it's based on the location of your number. Again, I have a number, or it's in reality a coefficient, somewhere in front of x. When it's attached to the x and still underneath the house, it's the horizontal, and it's gonna be everything's gonna be the opposite. So it goes back to dilations, your scale factor k. When you talked about dilations in geometry, if it was bigger than 1, your shape got larger. If it was less than 1, your shape got smaller. That's how it is on the vertical, which we'll see in a second, but here it's opposite. So when it's 3, it's actually going to be shrink by a factor of 1/3. We take the reciprocal. This is going to be really helpful. So 3 is like 3/1. We just got to take the reciprocal of it, 1/3. 1/2, the reciprocal down here would turn into 2/1. So 3/1, I take the reciprocal, it turns into that. 1/2, I do the reciprocal, it turns into that. 2/1, which of course is 2. So if it's attached to the x, still under the house, if it's a whole number greater than 1, it's shrink, do the reciprocal to get the fraction. it's already a fraction, it's a stretch to the reciprocal to get the whole number. If it's in front of everything, in front of the house, in front of everything, then it is what it's supposed to be. So 4 is stretched by a factor of 4, 1/5 shrink by a factor of 1/5. In this problem, clearly there's no coefficient. So you could put no or none. I believe I actually put none on the worksheet. So that's how I got scissors. If I can get the light to reflect on it. I know it's backwards, I'll put up in a second. That's how I got the first 5 transformations, right? Let's clear everything out, actually. Well, actually, I think I can leave it up for a second. So let's do this. High floating mean controls. Close that. Pull this up. Yeah. All right. So stretch or shrink, none, none. Like the x-axis, no, no. Y-axis, yes, yes. Horizontal shift right 2 units, vertical shift up 3 units. So everything matches up. Okay. Now let me get rid of it. All right. So that is those are the transformations. What about domain and range? Okay. Actually, let me back up. So before we even talk about domain and range, everything we just looked at, it's a square root. Everything's still going to be true for a cube root. Okay. So if we were going down the list, if you remember the list and you can pull it back up, we started with the horizontal shift, which is this +4. It's the opposite of what it's supposed to be, so it'd be left 4 units. Again, you need to go back and look at the chart. Or if you already have it in your paper, you can have it with you following along as I'm talking about this. There's no number after it, so there's no vertical shift, so we put none. There's a negative sign, but it is in front of everything. Ignore the 2. I'm just concerned about where this negative is. It's in front of x, but it's in a different place than this negative was right here. It's in a different place. Now it's in front of everything. So that's going to be a reflection over the x-axis, and there is no reflection over the y-axis. And then my 2, again, the 3 just shows it's a cube root. My 2 is in front of everything, which would be the vertical stretch. Again, you don't have to put the word vertical, but it's going to be stretched with a factor of 2. Okay. So now let's look at 1 and 2 on Desmos. Clear everything out. Let's actually leave the parent function here. I'm going to leave the parent function, so as I kind of build this, y'all kind of see how it goes. First thing, square root. It's on your Desmos keyboard down here at the bottom. So all you got to do is go click it, okay? So if we started with x, if we added our -2, there's our shift 2 units to the right, and it's red again. Let's change that. -2, 2 units right. My cursor is now after the square root, so the +3 makes it go 3 units up. And then when I throw the negative sign in front of x, that's what gets it to flip over to where it is. Okay. So we just did step by step each of the transformations that gets it from here to here. But now let's just look at our graph for number 1. Okay. Let's look at our graph for number 1. Again, I had my pen, it might be a little easier to draw and annotate, but it's kind of hard, so I might have to kind of look in the corner and watch my hands. Okay. If we're looking at our coordinate plane, top to down, left to right, we're talking about our domain. We're saying over our entire coordinate plane. Do we have an end that's going left forever? Not going to stop to -infinity x. Do we have an end that's going right forever? Not going to stop until it gets to +infinity x. And if I don't have one end going in each direction, then, what's the situation then? All right. So y'all can see with my square root graph, we already kind of looked at the parent function. Let me pull it back up. It's only going in one direction. Okay. I said in the notes during class that aren't on here, it's the square root graph is basically like your parabola turned on its side. But when we turn it on its side, if I had this bottom half, it would then fail the vertical line test. So that bottom side is gone. So we just have the one half. Okay. So I only have one end. All right. So going back to look at our purple graph, if we're talking about the domain, my one end I do have is going left forever. Gosh, that's so bad. I'm sorry. I'm trying to make it look a little better. My one end I do have is going left forever to negative infinity x. Again, these are our x values. This is just going to keep going left forever. There's nothing that's going to stop it. Now going to the right. So for my domain, the first number is how far left it goes. The second number is how far right it goes. So the farthest right that it goes, you almost kind of want to come down here now, look at the x-axis is -2. Okay. I actually click on it. This point is -2, 3. My purple line doesn't go any further to the right than okay. So that means the farthest right it goes, the farthest right x value is -2. And in this situation, it's a hard stop in -2. Okay. I don't have an open point, an open circle at -2, 3. It's not like in the growth and decay when we had in the last unit, when I had a curve that kind of flattened out and was approaching the x-axis and never got there. This is a hard stop at -2. So when it's a hard stop like that, we don't do a parenthesis, we do the bracket, the one that's more square looking. Okay. So that's our domain. And then our range, again, same question, but going up and down. Same thing we're trying to look for. Do I have one end going down forever to negative infinity x? Do I have one end going up forever to, excuse me, negative infinity y? Excuse me. Do I have one end going up forever to positive infinity y? And if I don't, again, what's the situation? So again, just one end. While it is mostly going left, this is still slightly going up. And as it continues to go to the left, it's still going to slightly go up, but there's nothing that's ever going to stop it from going up. So it is going to go up forever to positive infinity. Okay. This is where it can get a little confusing. Even though it's going left to go up to positive infinity, I'm not going to put positive infinity first. Okay. It's when I'm talking about range, the first number is the lowest it goes, second number is the highest it goes. I say that because people get confused sometimes. Positive infinity should never be your first number. Okay. So we're going to go ahead and put positive infinity. Again, kind of the reason why I'm doing this first is, especially these ones where it just has one end, go ahead and figure out if it's going to negative infinity, positive infinity, whichever one is whichever one, and then figure out the other side. So it's going up to positive infinity. Now I got to say how far down the coordinate plane does this purple line go? Again, if we go back, click on this graph, I got 2, I got 4, it's halfway between, which is 3. So it's a hard stop. That y equals 3. There is no, kind of is a class. It's going to be kind of messy looking here, but there's no part of my purple line anywhere down here. I know it went up a little bit, but y'all get the point. So 3 is the lowest y value that I have. So I'm going to put 3. And again, it's going to be a bracket. And if you look at your domain and range on number 1, you will see it's exactly what I wrote. Okay. Now let's just talk about the domain range real quick for cube roots. I also need to show you how to type cube roots, and that'll kind of wrap up the video. So make sure you got this down if you don't have it, because I'm gonna clear it out. Let's get rid of that. All right. So now do a cube root. Can't just click on this. You got to go to functions. You're going to scroll all the way down. Come here, the nth root. The n, remember, if you remember, it's called our index. Okay. When I click on it, you can already see the cursor's up here. Tell me what kind of root I'm supposed to have. So I'm going to go ahead and put a 3. And then after that, you can add in everything else. But let's start with the cube root of x. Capital. There we go. All right. So if y'all see the cube root of x, this half still kind of looks like a square root graph, this upper half going this way. But instead of a bottom half curling back under, now it's flipped going to the other side. So now I can have what I said looks like a whole graph because I don't have the other end going under the end that's already there, making it not a function. Okay. And again, y'all are going to see how this kind of looks like the regular x cubed graph in the next unit. But let's just focus on this one. Okay. So again, same idea here. We can start with the +4 underneath and move it 4 units to the left. Well, now we go all the way in front. Again, make sure this cursor's in front. It's not up there at the 3. When we stick the negative sign, it's actually going to be a reflection over the x-axis. Okay, and again, just trying to show you all the difference. If we'd have done over the y-axis, then it would have flipped it over there. Okay. The x-axis just flipped it up and down in place. It didn't try to flip it back over the y-axis. Now I'm going to put that 2, and y'all can see that it kind of makes my curves a little wider. Okay. So now I've got this blue graph. Again, I'm trying to identify the domain and range, but the good thing now with my cube root graphs is I have 2 ends of my graph. So when I'm trying to talk about the domain and I say, what's my domain? Do I have one end going to the left, one end going to the right? I do. That end's going to the left forever. Nothing's going to stop it. This end's going to the right forever. It's going to stop it. There's no holes in the middle. When I say a hole, it doesn't mean my graph suddenly stops here and then picks up down here and this middle blue line is missing. So there's no holes or anything. So my domain is simply going to be on that colon. My domain is simply going to be negative infinity. God, it's terrible. Negative infinity to positive infinity. Okay. And then my range, again, similar idea. But now instead of an end going left and right, I'm talking about up and down. So this end, even though it's mostly going to the left, is still slightly going up. This end, even though it's going to the right, is still clearly slightly going down. So I have one end going down to negative infinity y, one end going up to positive infinity y. So again, it's going to be negative infinity, positive infinity. But again, you need to be careful. Even though the left end is the one that's going up to positive infinity, that doesn't mean the positive infinity goes first on the left. My range is lowest value to highest value. Lowest value is negative infinity y. Highest value is positive infinity. Okay? So your transformations are going to be the same for everything. Talked about domain and range for your square root graphs, which is going to be all the left-hand side of your paper. 1, 3, 5, 7. Lights are flooding off as well. 1, 3, 5, 7. We talk about the domain and range for the cube root graphs. All of those are on the right side of your paper. So we've covered the entire worksheet. Yeah, set in class 4 extra credit. I'm not gonna be able to sketch it on here, because I don't have my pad. But if you want to do a sketch of all these graphs, including number 1 and 2, which I already have typed out, and are again on the screen right now, y'all can still see them. Okay, so that would be number 1. That would be number 2. If y'all want to sketch them, You need to actually, do the X and the Y axis and mark them off, kind of by twos like I have here, or however your graph is displayed. Might want to try to show the intercepts if y'all can. I think my graph looked a little wonky when I originally drew it, but this is our intercept. This is actually also going to be our vertex. The point that's in the middle of our graph. Let me try to add another number so y'all see what I'm talking about. So now if we move this up, let me move it up. And now if we move this up, vertex, so it came up. It's kind of hard to see, but you can kind of put it in the middle here at -4.3. But that's not the x-intercept or the y-intercept. The x-intercept's right there, the y-intercept's right here. And those are kind of close. Okay. So the quote-unquote vertex would be right there. X-intercept would be right there. Y-intercept would be right there. So, I kind of need that level of detail to get your full extra credit. Okay. If you just do a x-axis and a y-axis, no numbers on it, and just draw a shape, give you a point of extra credit, but you're not getting the full extra credit. So 2.5 points of extra credit per graph, including, again, number 1 and number 2, even though I've already typed out the main details of those for y'all. And then the sketches of the other 6 graphs as well. 2.5 points times 8 is 20 points. So y'all get up. Okay. Hopefully that's comprehensive enough. I'm gonna take the glasses off to reduce the glare. So that should be able to get y'all through this assignment. If y'all have any other questions, send me a message or mine, or ask me in class, and I will see y'all later.